So in this problem, we need to determine the equation of an ellipse whose focus is at the point 2, 1 with directrix given and the eccentricity is 1 over 2. Let's begin. We'll try to understand the problem graphically first. So here we consider a vertical straight line which is going to be the directrix of the ellipse. Its equation is given x minus 5 equals to 0. Now, we are going to consider a line that is perpendicular to the directrix line, and that line is referred to as the axis of the ellipse because on this axis line, we have the focus of the ellipse. The coordinates of the focus are given as 2, 1. Here, a point P with the coordinates x, y is chosen on the plane containing the directrix and the axis. Now, point P is the locus of the ellipse and its position is very important. It is chosen in such a way such that if we take the ratio of the length PF to that of the perpendicular length PM, then this ratio is always a constant with a value less than 1. And this constant is referred to as the eccentricity of the ellipse, and it's already given that the eccentricity has a value equals to 1/2. What we'll do, we'll take this condition that 2 times PF equals to PM and use this to obtain the equation of the ellipse. We'll begin by first finding out the length of PF. PF can be easily obtained by using the distance formula as we are provided with the coordinates of the endpoints P and F. So 2 gets multiplied to the square root of, so here we'll take the difference of the x coordinate, so that's x minus 2, we square it and then add it to the difference of the y coordinate, so that's y minus 1 whole square. This will be equals to PM. So PM is the perpendicular distance of point P from the directrix line. So here we need to use a formula to find out the perpendicular length. So if we have a point P with coordinates x1, y1 and a straight line with the equation ax plus by plus c equals to 0 expressed in its general form, then the perpendicular distance of point P from the straight line, which is denoted by PM, will be given by the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. So here a and b are going to be the coefficients of x and y of the straight line. Now in that case, we'll take the absolute value. Inside the absolute value, we'll consider a ratio. We'll start with the numerator. So here we'll first try to express x minus 5 equals to 0 in the general form of a straight line, ax plus by plus c equals to 0 to get 1 times x. So here the y term is missing. So what we can do, we can rewrite it as 0 times y. Minus 5 equals to 0. Now we'll consider the coefficient of x, which is 1. 1 will get multiplied to the x coordinate of point P. So we have 1 times x added to, now we'll take the coefficient of y, so that's a 0. 0 will get multiplied to the y coordinate of point P, so that's y. And then we have the constant term, we'll need to add it since it's negative 5, so we have negative 5. Divided by the square root of, we'll have to take the sum of the squares of the coefficient of x and y, since they are 1 and 0, we'll take 1 squared plus 0 squared. Now let's do one thing, let's square both sides to get 4 multiplied to x minus 2 whole squared, added to y minus 1 whole squared, and this will be equals to, so in the numerator we have x minus 5, so we have to square this, x minus 5 whole square, and in the denominator that's simply 1, squaring it also gives us 1. Now when we simplify this, we're going to get the final expression. So we have 3x squared plus 4y squared, negative 6x minus 8y minus 5 equals to 0, and this is the required equation of the ellipse, with the condition that the focus is at the point 2, 1 and the directrix and eccentricity is also known.